Hello, this is an update video for the project that I've been working on, an Arduino integrated robot arm. In this video, I will continue to showcase new changes made to the design, new part prints, electronic setup, and demonstrations of the product so far. One of the main issues addressed in the previous video was concerning the radio communication setup and the inability to transmit and receive data between radio modules. After about a week of troubleshooting the issue, I was on the verge of giving up on using radios via mean wireless communication and instead looking towards BLE Wi-Fi communication. However, I did a little bit more digging online and stumbled upon an Arduino forum post by user Robin2 who provided example code for testing the connection between the Arduino and the NRF24 module. He also provided an extensive tutorial on using the radio module on the forum, so I'll post a link in the description below. After doing some rewiring and uploading the code from the post, I was able to narrow the issue. Up until now, there hasn't been a sufficient cross connection between the Arduino and the radio modules, preventing them from working. After swapping the Arduino and the RF modules a couple times, as well as using the example codes provided on the forum tutorial, I was able to reestablish radio communication between the modules again and henceforth continue with the project. Several more prints were made for the new Grappler assembly. The first part, the palm of the claw, acted as the base for all other assembly components of the Grappler. Two gear joints are placed adjoining together. One of the gear joints is attached to the SG60 servo motor horn to transmit rotational motion on the gear and move other components. Four additional components are connected to the remaining assembly. This includes a claw arm for grabbing and a smaller arm to support and hold the claw arm. Each of the components are held together with 4mm diameter, 60mm long bolts, and 4mm nuts. 3 MG995 servo motors and 3 SG60 servo motors are part of the robot arm assembly, which provides 6 degrees of motion. For testing, each servo motor along with its attached component is connected to the Arduino Uno and an NRF24 module acting as a receiver. The motors move based on data received from the transmitter module connected to a potentiometer. Input from the potentiometer through an analog pin ranges from low, 0, to high, 255, with everything in between being transmitted via the radio module. The MG995 servo motors are connected with the Arduino first for testing, all of them working fine aside from load issues causing the second joint to move downwards. This was quickly fixed by adding additional support hooks used before between the base plate and the first joint that prevented it from falling back and forth. The wrist joint servo moved fine as well. Issues started to arise when it came with the pitch and the Grappler servo motors. The SG90 servo motors have a specified torque of 2.5 kilograms when operating at 5 volts, meaning that they can move a max load of 2.5 kilograms, that is 1 centimeter distance apart. However, if it exceeds these constraints, the servo motor may fail to provide sufficient torque to move any mass attached to it. The pitch servo motors were able to handle the load for a short duration before the gears then began to give up. The Grappler gear responsible for opening and closing the claw faced the same issue a bit later, working fine initially. However, more testing caused the servo motor to heat up due to the stress on internal components from moving the mass of several components exceeding its torque threshold. The motors continued to move erratically during testing, with only the pitch servo maintaining some semblance of stability, during which the Grappler servo responsible for opening and closing action of the claw only moves a certain degree of range before locking it in place, regardless of adjustments to the potentiometer. It all boiled down to the fact that the servo motors were just not powerful enough to provide the rotational motion for the claw and the pitch of the robot arm, given the design parameters. The only two ways to fix this issue were by redesigning the components again to better suit the low capability of the SG60 servo motors, which have already malfunctioned and thus wouldn't work either way, or using an even more powerful servo motor while maintaining the same design details. In this case, using the MG995 servo motors would be a suitable replacement, as I still had some on hand. With a torque of 9 kg per centimeter, it will be better suited for facilitating rotational movement. The main downside to this arrangement is the added mass being supported by the arm assembly due to the MG995 motors being heavier, with a mass of 55 grams compared to the 9 grams of the SG90 servo motor. In the meantime, these parameters have to be considered when making design adjustments to the claw assembly to mitigate any issues later on in testing. To this end, I will conclude this third update video of this project. So far, I have been able to make substantial progress and overcome some hurdles earlier. However, there are still things that need to be further worked on before bringing this project to a close. I will provide another update video where I will showcase and discuss changes made and the overall status of the project thus far. If you have any suggestions or questions, feel free to leave them in the comments below. And once again, if you enjoyed this video and this series of update videos, please leave a like. Thanks for watching.